Okay, so now that we have what this data set is, what I'm going to do is I'm going to hop over and show you where you can find all the different pieces so that you can change what type of map you're dealing with. So the first part is, obviously you can change base maps. That's not actually going to change the type of map. So you'll remember back from class that we have choropleth maps, which this currently is. You have dot density maps, you have graduated symbols maps, isoline maps, all of those different types of things. And so if you want to change what type of map it is, you want to make sure that you are understanding what are the data considerations for each of those types of maps. You can go back through the lecture to look at some of those things. I'll make sure that that is posted. But in terms of the nuts and bolts of actually how to do it, you're going to want to deal with the edit layer style in this particular case. So with the edit layer style, if you are clicked on one of your layers, you can head over. Up at the top, it's going to tell you what things are being adjusted by. What do I mean by that? So right now, this is currently being broken up by the species count. So it's going to take species count and it's going to say how many different species are there in there based on that attribute and what can you do with it. So the first thing you can do is the counts and amounts by color. That's going to be your normal choropleth map. That is what you currently have. If you click on the style options, this is where all of those options come up, so you can adjust where these colors are breaking. You can change how this is being adjusted in the legend. You can classify your data, all of those different sorts of things. So this is, and you can also choose if there's a subdivision of that category, right? So choose a field to divide by. So this is something that is your most common base of choropleth map. If you click on the little edit button, you can adjust what the colors are going to be. One of the things I will say with this is that there is kind of a limited amount of color schemes. Unlike in some of the Arc Pro things, there's less adjustment that you can do with the color scheme. But you can still adjust. There's a variety of different things. You can change the outline color here. You can change the transparency, and you can also, if you want to have an outline pattern that is different from just a normal line, that is also where this is going to be. So all of this is fairly, or should be fairly straightforward or standard for how to do that. But this isn't the only type of option that we have. This is a standard option, but it's not necessarily the best option for the data that you have. So again, go back to what is the data. So we also have counts and amounts. This is going to change this map into a graduated symbols map or proportional symbols map. Now, what you can see here is that this is very clear that the graduated symbols are a little bit too big for what they're in. So they're overriding on top of each other, but you can adjust that also in the style options. So much like you have in the choropleth map, you can adjust what the size is in this case. So maybe I want to drop this down so that I have, this is the species amount now. Now, if I zoom in, what you'll notice is that it's drawing more or less in the center of where that is. There is also, in this case, some sort of background outline that you can kind of see going on here. And you can also have some sort of background symbol if you want. So I could change this into a base color, and that would be adjusted from there. There are pros and cons to using this one, obviously, but it can be useful if there's direct counts of things instead of rates, which are typically speaking better for choropleth maps. So you also can classify the data, you can adjust what the sizes are here, you can adjust the transparency, the rotation, all of those different things, and you can also change the type of symbol. So that is going to transition it into a graduated symbols map. You can do both, which is using the color and size. Now this lets you do it by two things. You'll have one thing that's by size and another thing that's by color. Be cautious with these ones because this is where you start getting into some things that could be a little bit more confusing. In this particular case, if you only have it by one, this is redundant. You have both color and size. That's a redundant thing. You don't really need that. But you could do it by a secondary thing where you have, let's say, a growing amount by species and then another one that is how much protected area, that is the color. So you can adjust it. This would be more or less for two things though. The second thing you can do is a dot density map, or one of the other things you can do is a dot density map. Now, you'll remember from a dot density map that this provides random points based on the count. So in this case, you have one dot is equal to 8 species, right? So this has 8 different species attached to it. and that's how many dots there are. You'll want to make sure that this is some sort of number that makes sense. You'll also want to balance out, because there are some very large areas in here, sometimes that means that you'll end up with things kind of in some sort of lake, for example, right? So you could maybe end up with things in a river that shouldn't be in a river. You can see one in here that ended up in, there should be one in here I thought I saw, yeah, right there, that ended up in the middle of the lake. So you do have those pieces that can maybe get in the way of things. Can be very useful again for amounts and counts, which this one currently is as a species count. The one thing you want to make sure you do not do here is have a one-to-one. So you don't want to have one dot equals one species. If you had that, right, that would actually be under one of these, right? So you could instead, every single one of these is going to be a unique observation. So the implication of one-to-one, if one dot equals one species, is that is the location in which it was found. You're not going to want that in this particular case. But it is a species count, so maybe you want to do something like this. One of the things to keep in mind, though, obviously, is that different sizes of things, and so maybe this isn't the best option. It might be, though, depends on what you're trying to do. And so those are kind of the main ones that you have for one thing. Right, so you've got the chloropleth, you've got the dot density, you've got the graduated symbols, and you've got the graduated symbols and color. If you add another field, which you can do, I'm going to just show this, you can have more things. So now I have it by 2. So in this case, what I have is I then have what's the predominant category, I have category and size, I can start doing charts. I can start doing comparing one thing to another, so I could do the number of species by the amount of protected areas. That would be what a compare A to B is. I can do a relationship, so is there some sort of geographic relationship? Think of this kind of like a weighted regression. Is there anything that's happening there, and where is that happening or not? So for example, I'm just going to show the compare A to B, and I'm going to say species count by percent protected area, and I'm going to have that as an option. So in this case, what we have is we have the symbols of blue to red. So I can maybe change this blue to green or some other thing. Maybe I'm going to do this one. And I'm going to show the ratio of A to B. So what that is saying is I am doing species count divided by percent protected area. And that's what it's going to create this. Now, I can do center at average values. This is going to do kind of like a normal distribution, or I can have equal values across. And then I can say done. So what this ends up showing you is that if you have, for the species count, if you have a high amount of species and a low amount of protected areas, that's going to give you a bigger value. Again, be careful with this because you are dealing with different types of things, and so you want to make sure that you're doing apples to apples comparisons to ensure that this is going to be a relevant metric for whatever you're doing. So this is going to be another way that you can take a look at things. So with all of these different options, the charts, the integrated charts, the graduated symbols, the dot density, 2 different colors, the chloropleth map, all of those different options, you're going to want to fundamentally think about what type of data you have, what that means, and whether or not the map that you are creating is a good fit for that. You can also take, so point maps are obviously going to be a little bit different, so you can also take a look at your point map. You can also do some things, so you can add a field in here if you would like to say, oh, I don't know, I want it by a unique identifier, I want it by the family or the order of the species, so I could do that. I can say, okay, well, I want it by order. Now I have this unique symbols options. This pops up over here. These are all the unique orders of things that are critically endangered in the tropical and subtropical grassland, shrubland, and savanna. So those are the different types of maps. It's fairly simple to navigate, is what I'll say. It's less simple to figure out what is going to be the most effective thing for what your data is and what you want it to be. So that's what I've got for the different types of maps. We'll be back with graphs in just one sec.